In this video, I'm just going to give you a quick introduction to radicals, including vocabulary. We'll work on simplifying, operations, and equations in separate videos. So when we talk about a radical, we're using this radical symbol, right? This root symbol, as you might hear them called. So we can also see roots. Roots are then later in other sections talked about as x-intercepts if you're going into like a college algebra course. So we'll stick to the term radicals for now. There are two main pieces to this radical that we need to be able to identify. First is the radicand. This is the argument, the value inside of the radical symbol. All right, this is what we were actually taking, said square root, cube root, or radical of. And then we have our index. This is a little number written on the outside of the radical telling us what exactly we're looking to do. So I have an example over here on the left-hand side. On the left-hand side, we're doing what's called, if we wanted to say this in words, the cube root of 27. Now, what we're actually thinking in our heads, if we're trying to solve this without a calculator, is that we are looking for what number cubed or raised to the third power is 27. Essentially, our radicals are the opposite of our powers, our exponents. So what number cubed is 27? Well, the answer here would be 3, right? And we could double check our work here by just saying 3 to the third power is equal to 27. And we could also do this in a calculator to sort of verify that this is exactly what we're seeing. Now, we needed these in order to undo our square roots, undo our squares. So another thing to note is whenever we have a radical symbol without an index on it, that is a square root. Most of you guys have seen this before. So when you see something like this, again, in terms of what we're thinking, what number squared is 9. And again, this is pretty straightforward. This is still 3. One thing I wanted to mention about this. One is you can always keep in mind that there is that invisible 2 hanging out on the outside of this radical. 2 is that with the square roots, these are especially important, any of the even roots actually, that we are specifically talking about the principal square root. And what this means is if I wrote this question, it would be very different. If I had an example where I just said, find the square roots of 25, there's actually 2 answers to this. 5, and the other answer is -5, right? So 5 squared is equal to 25. -5 squared is also equal to 25. So, in terms of square roots, most numbers, every number that has a square root, with the exception of 0, have 2. So, when we say principal square root, that strictly means only the positive square root. So, our answer to this is just 3, not -3 as well. And this is because we want to think of our square root as being a function. And with our functions, when you have one input, you can only have one output, right? So that's exactly where we're headed. Might as well, in this introduction, go ahead and do one example where we graph as well. So that's what we're going to do next. So our radical functions, let's just start with the most basic of our radicals, the square root of x. This radical function we could graph, we could make our table, and come up with our graph. If we were doing this table by hand, we didn't have our sweet calculators, what we would want to do is we would want to choose numbers that actually work out nicely, right? As I'm choosing numbers, I would choose an x like 4, because the square root of 4 is equal to 2. I would choose 1, because the square root of 1 is equal to 1. 0. I would choose nice, pretty, perfect squares, and that would be a good way to start the graph out. I could obviously go get decimals as well, especially with the calculator, but I'm sticking with my little pretty answers. And then we could graph these. So we've got 0, 0, 1, 1, 4, 2, hope that's 9, 9, 3. And we start getting this little half of a parabola sort of on its side. Now, if we plugged in negative numbers, or we looked at the negative numbers in our table, what we're going to find out is this is an error. The square root of -1 is a imaginary number. It's not something we discuss in Math 92. It does not exist on this real number thing. So there's nothing over here on this side of the graph. This side of the graph is just sad. Now, what are the other things that we might want to know about said graph, right? What do we normally ask when we do graphs? Well, we could be asked, what's the domain? From the graph, we can see, well, 0 and more, those are all things that are possible, right? 0 and up. We could also think about, what are we not allowed to plug in here? Is there any issues? And as we just said, there's no negative numbers, right? So there's actually two ways you can write this domain. You could write it using our interval notation. We started at 0 and we went up to infinity. Or you can write it by saying x has to be greater than or equal to 0, cannot be negative. Technically, we should write this as set builder, since your domain is a set of possible values. Now the range, this is something that usually you're not even asked in, say, a Math 96, but definitely feasible and something we are capable of doing. Now the range is our y values. So we look down our y-axis, we don't have a graph until 0, and then we have our graph going up forever, right? So our range for this particular graph is the exact same thing, 0 to infinity. If we wanted to write this out using set builder, we'd have to write y is greater than or equal to 0. And that's true for any y that fits that bill. So there's our domain and range. We could even get into x and y intercepts if we wanted. This particular question is pretty easy for those. I will revisit this when we go through the domain examples with radicals in a later video.